In the summer of 2026, Las Vegas will begin to pay for a debt it never knew it was accumulating. A debt held not in dollars, but in degrees. For decades, the city waged a war against the desert for water. It drilled tunnels, recycled every drop, and tore out its own lawns to survive. But it was looking at the wrong enemy. The real threat was never just the lack of water. It was the air itself, the relentless, unforgiving, and ever-present sun. In May of 2026, the first triple-digit heat wave of the year will arrive weeks ahead of schedule. Not a catastrophe, not a record breaker. Just a warning. 105 degrees Fahrenheit, then 108, then 112. The city's power grid will begin to scream. The asphalt on the strip will soften like warm wax. The calls to emergency services will tick upward in a rhythm that is terrifyingly familiar. What is the hottest temperature you've ever truly felt? The kind that presses on you, that you can feel in your lungs. Let us know in the comments below. What you are about to witness will redefine what a city can endure. This isn't a story about a bad summer. It's about a city reaching a physical limit, a point where concrete, steel, and human bodies begin to fail. Before we begin, a brief but critical note. A massive number of people will watch this story, but an astonishingly small fraction of you are actually subscribed. If you believe in this kind of deep dive, uncompromising storytelling, taking 1 second to hit subscribe is not just helpful. It is a lifeline for this channel. It is an emergency click for us. It ensures we can continue to make these documentaries. Thank you. Let's begin. Las Vegas was designed to conquer the desert, and yet it made itself uniquely vulnerable to the desert's most powerful weapon, heat. The city that was never supposed to exist was built on a foundation of air conditioning and cheap power. The very tools that made life possible here also created a trap, a city-sized engine that by its very design makes itself hotter every single year. So the real question is, what happens when a city built to defy nature is finally presented with a bill it cannot pay? What happens when the heat just doesn't stop? To understand the crisis of 2026, you have to understand the city's original sin. It wasn't greed, it was amnesia. Las Vegas forgot what it was. The city's master planners, its developers, its architects, they all saw the Mojave as a blank canvas, not an active participant. They saw land to be paved, subdivided, and illuminated. They did not see a complex thermal system they were fundamentally altering with every ton of concrete they poured. The post-war boom that built this city was fueled by a singular, seductive idea: that technology could erase geography. Air conditioning didn't just cool rooms, it cooled the very idea of the desert. It turned an environment hostile to human life into a backdrop, a theme. The street grid tells the first part of the story: long, wide boulevards of black asphalt designed for the automobile, not the pedestrian. These roads act as colossal solar collectors, absorbing radiation all day long. In the 1960s and 70s, as the suburbs sprawled outwards into the valley, they created thousands of square miles of this dark, heat-absorbing surface. Single-family homes with dark roof shingles, surrounded by rock lawns and concrete driveways, replaced the natural desert scrub. The desert floor, with its lighter-colored soils and sparse vegetation, has a relatively high albedo. It reflects a significant portion of sunlight back into the atmosphere. What Las Vegas built in its place was the opposite: a dark, sprawling surface with a low albedo designed for maximum heat absorption. It was not a conscious choice. It was a default setting, copied from suburban designs perfected in Ohio and Pennsylvania. Climates that had the opposite problem. They were designed to hold heat in, not repel it. This process has a name: the urban heat island effect. But in Las Vegas, it is more than an effect. It is the core of the city's identity. An urban heat island is typically a few degrees warmer than the surrounding rural landscape. In Las Vegas, the differential can be staggering. On a calm, clear night, the temperature difference between the heart of the strip and the open desert 20 miles away can be as much as 10 to 15 degrees Fahrenheit. The city does not cool down. The heat absorbed by the concrete and asphalt during the day radiates back out all night long, a process that robs the population of the natural relief that nighttime cooling once provided. To put that in terms that mean something, imagine every square foot of asphalt and concrete is a brick that has been sitting in an oven all day. At night, the oven is turned off, but those millions of bricks continue to release their stored energy, warming the air around them for hours after sunset. We just talked about how the city itself becomes a heat engine. The infrastructure that enables this is the power grid, and it's the first thing to show the strain. Have you ever experienced a power outage during a major heat wave? What was that like? Share that experience in the comments. Hearing those stories is crucial for understanding the real human stakes of what we're discussing. The city's power infrastructure was a modern marvel, designed for peak demand on the hottest summer days. But the definition of hottest was changing, and the definition of peak was becoming a constant state of being. The grid that serves Las Vegas is a complex web of natural gas power plants, sprawling solar farms, and the iconic Hoover Dam. That system was built for a world of predictable extremes. It was not built for extremes that last for weeks on end. It never was. The heat wave of May 2026 will expose the network's fragility in ways that models had predicted, but officials had hoped to avoid. It begins with the transformers. Those gray cylinders you see on utility poles or in metal boxes in suburban backyards. They are filled with mineral oil, a liquid that both cools and insulates their internal windings. They are designed to operate within a specific temperature range. When ambient air temperatures soar past 110 degrees and stay there, and the demand for power surges as every air conditioner in the valley switches on, those transformers get hot, dangerously hot. The oil inside begins to degrade, the efficiency drops. They become in essence ticking clocks. Pushed past their thermal limits, they can fail, sometimes explosively. A single transformer failure can knock out power to a dozen homes. A cascading failure at a substation can plunge thousands into darkness. And in Las Vegas in July, darkness means heat. Unbearable, life-threatening heat. If this story is already making you think differently about the fragile systems that support our cities, take a moment to like this video. And if you know someone who lives in a place battling extreme heat, consider sharing it with them. The awareness that comes from these conversations is one of the most powerful tools we have. Starting that dialogue matters more than you might think. The power company, Nevada Energy, will have spent billions preparing for this moment. They retrofitted substations, invested in smart grid technology to reroute power around failures, and ran public service announcements begging residents to conserve energy. They will have pre-positioned repair crews like an army preparing for an invasion. But they are fighting a war on two fronts. The first is demand. In a heat wave, air conditioning isn't about comfort. It is classified as life-sustaining medical equipment. Demand for electricity doesn't just rise, it goes vertical. The second front is the physics of the grid itself. The power lines that crisscross the valley are made of aluminum. As they heat up, their electrical resistance increases. This means that a certain percentage of the electricity they carry is lost as heat before it ever reaches a home. The hotter the day, the less efficient the delivery. To compensate, a power plant has to generate even more electricity, burning more natural gas, putting more strain on its own cooling systems just to deliver the same amount of usable power to the end user. It is a vicious, self-reinforcing cycle. And then there is the problem of water, the one Las Vegas thought it had solved. The city's new power plants are marvels of efficiency, but many still rely on water for cooling. The massive solar arrays in the desert are a point of pride, but their efficiency also degrades in extreme heat. The panels get too hot to function at their rated capacity, a cruel irony of physics, and Hoover Dam, the great symbol of the city's birth, is a shadow of its former self. Years of drought, as documented in the battle for the third straw, have left Lake Mead dangerously low. Less water moving through the turbines means less hydroelectric power available. The reliable, cheap baseline energy that Vegas was built on is now a variable, unpredictable source. The heat wave of 2026 doesn't just stress the grid, it reveals that the solutions for one crisis, the water crisis, are inextricably and dangerously linked to the next one. The physical city itself begins to buckle. The Department of Aviation at Harry Reid International Airport will have contingency plans that read like science fiction. On the hottest days, with temperatures on the tarmac exceeding 150 degrees Fahrenheit, they prepare for ground stops, not because of weather in the sky, but because of the air on the ground. Extreme heat makes the air less dense. Less dense air provides less lift for an aircraft's wings. A fully loaded passenger jet might require more runway to get airborne than is physically available. Operations slow down. Flights are delayed or canceled. The economic lifeblood of the city, the steady flow of tourists, begins to clot. The roads are another silent victim. Black asphalt under the unforgiving Mojave sun can reach surface temperatures of 160 to 180 degrees Fahrenheit. At these temperatures, the binder that holds the asphalt together begins to soften. The road surface becomes pliable. Heavy trucks can leave ruts in the softened pavement. In the most extreme cases, the surface can experience bleeding, where the liquid asphalt binder bubbles up to the top. It makes the roads slick and dangerous. City road crews, forced to work in the pre-dawn hours to avoid the worst of the heat, will be patching a city that is slowly melting in place. The expansion joints on bridges and overpasses designed to allow concrete to expand and contract with temperature changes will be pushed to their absolute design limits. A failure here is not just an inconvenience. It is a structural crisis. The city is hollowing out from the heat. This was not a problem of the future. It was a problem of the past, catching up to the present. The very materials used to build modern Las Vegas, the vast stretches of asphalt, the concrete tilt-up construction of its endless warehouses and strip malls, the dark-colored roofing materials, were all chosen for cost and speed. They were never evaluated for their thermal performance in an era of accelerating climate change. The city had built itself a furnace and was now desperately trying to figure out how to live inside it. The historical context is damning. When the Flamingo Hotel opened in 1946, effectively kicking off the era of the Strip, air conditioning was a novelty, a luxury. The architects of that era still used some traditional desert design principles: overhangs, shaded walkways, buildings oriented to minimize direct sun exposure. But as the city boomed, these subtle, intelligent design features were abandoned in favor of a brute force solution: bigger and more powerful AC units. The architecture became generic, placeless. A glass box that works in Seattle was built in Las Vegas, the only difference being the size of the HVA system on the roof. This philosophy, repeated thousands of times over, is the genetic code of the city's heat problem. Every shimmering glass tower on the Strip is a monument to this thinking. During the day, they create intense glare and hotspots on the streets below. They are also incredibly inefficient to cool, turning into greenhouses that require immense amounts of energy to keep habitable. By 2026, the city will have known this for years. It will have started to fight back, not with one grand project like the third water straw, but with 1,000 smaller, more desperate ones. The first front in this new war is the strategy of whitening the city, the primary weapon: cool pavement. This is a special sealant applied to asphalt, a grayish-white coating designed with a high albedo to reflect sunlight instead of absorbing it. The initial pilot projects will have shown remarkable results. In a handful of treated neighborhoods, surface temperatures on the roads will be 10 to 12 degrees cooler than traditional blacktop. The ambient air temperature at pedestrian level will be measurably lower. The city will launch an ambitious citywide program to coat thousands of miles of residential streets. But the plan, audacious on paper, will collide with an unforgiving reality. The cost is enormous, the material is expensive, and the labor to apply it is intensive. The sealant also wears down under traffic and needs to be reapplied every few years, creating a permanent new line item in the city's budget. It is a tax not just on survival, but on physics itself. There will be other unintended consequences. While the coating cools the street, the reflected sunlight has to go somewhere. It bounces onto pedestrians, into windows, and onto the walls of adjacent buildings, in some cases increasing the heat load on the buildings the project was meant to protect. Drivers will complain of intense glare. It is a perfect example of the solution-new problem cycle. The engineering fix for one issue creates a host of others that were never anticipated. It was not simple. It never was. The second front will be a desperate push for green. For decades, Las Vegas viewed trees and grass as enemies in the war for water. The famous Cash for Grass program paid residents to tear out their lawns. It was a stunningly successful water conservation measure. But in the war against heat, the city will have to reverse course, at least in principle. The new mantra will be, the right tree in the right place. Urban foresters will be tasked with an impossible mission: dramatically increase the city's tree canopy without breaking the water bank. They will focus on planting drought-tolerant desert species like palo verdes and mesquites along pedestrian corridors, in parks and around public buildings. The goal is to create shade, the most effective and low-tech form of cooling known to man. The shade from a single mature tree can lower surface temperatures underneath it by 20 to 45 degrees. But trees need time. The benefits of a tree planted in 2026 will not be fully felt for a decade or more. And they still need water, even the drought-tolerant ones, to get established. The city will be trapped in a brutal trade-off: use precious water today for a cooler tomorrow. The debate will rage. Critics will point to the hypocrisy of a city that bans grass while planting thousands of trees. Proponents will argue that the cooling benefits and the reduction in air conditioning energy use that comes with shade will ultimately lead to a net water savings. There will be no easy answer. The city is trying to correct 50 years of poor planning in the span of a single decade, under the duress of a climate that is changing faster than the trees can grow. While the city's infrastructure groans and its planners scramble, the true cost of the 2026 heatwave will be measured in human health. It is a silent, insidious killer. Unlike a flood or an earthquake, a heatwave doesn't leave a trail of visible destruction. Its victims are often found indoors, alone. Emergency rooms at UMC and Sunrise Hospital will see a steady, grim procession. Heat exhaustion, characterized by dizziness, nausea, and weakness. And its far more dangerous cousin, heat stroke. Heat stroke is a catastrophic medical emergency. It occurs when the body's internal temperature regulation system fails completely. The core temperature rises to 104 degrees Fahrenheit or higher. The person stops sweating, their skin becomes hot and dry, confusion and disorientation set in, followed by seizure, coma, and if not treated immediately, death. It is a brutal, rapid system failure, and the people most at risk are a reflection of the city's own unseen vulnerabilities: the elderly whose bodies are less able to regulate temperature, the very young, people with chronic medical conditions like heart disease or diabetes, and the city's massive population of outdoor workers. The construction crews building the next casino, the landscapers maintaining the resort's elaborate foliage, the valets jogging across acres of sun-baked asphalt, they are on the front lines. By 2026, OSHA regulations and company policies will have mandated early start times, frequent breaks, and cooling stations, but the economic pressures are immense. A delayed construction project costs millions. Workers, often paid by the hour, feel compelled to push through. The result is a predictable spike in heat-related illnesses every time the temperature cracks 110. It is a hidden subsidy for the city's growth, paid by the health of its most exposed workers. Then there is the city's homeless population. Thousands of people living without shelter in a city that becomes an oven for 4 months of the year. They seek refuge in bus shelters, under overpasses, or in the concrete channels of the flood control system that run beneath the city. The city and a coalition of non-profits will operate a network of cooling centers, air-conditioned public spaces where people can find temporary relief. But getting there is a challenge. Many are not aware they exist, or they lack transportation. For many, the apathetic lethargy induced by dehydration and heat exhaustion makes the walk to a cooling center an insurmountable obstacle. The heat doesn't just threaten them, it immobilizes them. The deaths that occur in these forgotten corners of the city will rarely make headlines. They become statistics, tracked by the coroner's office, another dataset in the city's long, hot summer. The economic fallout will be more visible. The tourism industry, the engine of the entire state's economy, is built on the promise of escape and indulgence. A week of 115-degree heat challenges that promise. The iconic resort pools, once seen as an oasis, become scaldingly hot. The water temperature can climb into the high 90s, offering no relief. The resorts will have invested in massive water chillers, the same technology used for industrial processes, just to keep their pools at a refreshing temperature. It is an extraordinary expense, another layer of energy and cost simply to maintain the illusion of paradise. Daytime activity on the Strip will wither. Tourists will stay indoors, moving from the casino floor to the restaurant to the shopping mall through air-conditioned corridors. The street-level spectacle that defines Las Vegas, the costumed characters, the street performers, the crowds of people just taking in the sights, will vanish during the daylight hours, only to re-emerge in a more muted form after 10 p.m. The city will become nocturnal, not by choice, but by necessity. This has a direct impact on businesses that rely on foot traffic. Retail stores, smaller bars, and restaurants off the main resort corridor will see their revenues plummet. The heat acts as a filter, concentrating economic activity inside the self-contained worlds of the mega resorts and starving everything on the periphery. This is a problem that planners call thermal inequality. The experience of a heat wave in Las Vegas is drastically different depending on your income. A tourist in a suite at the Bellagio, moving through cooled interiors and swimming in a chilled pool, is insulated from the reality of the climate. A service worker living in an older apartment complex in East Las Vegas with a less efficient wall AC unit and a long commute on public transit experiences a completely different city. One is a playground, the other is an endurance test. The heat doesn't just create physical discomfort, it exacerbates the existing social and economic divides within the city. This friction, this growing gap between the insulated and the exposed, is a political crisis waiting to happen. The city's response, by necessity, will have to go beyond infrastructure. It will have to attempt to re-engineer human behavior. Public health campaigns on a scale never before seen will blanket the airwaves and social media. Hydrate or die. Check on your neighbors. Know the signs of heat stroke. They will be blunt, stark, and stripped of any marketing gloss. The message is not about comfort, it is about survival. There will be proposals for more radical interventions, laws dictating maximum indoor temperatures for rental properties, mandates that all new construction use cool roof technology, and other passive cooling designs. A heat tax on homes with exceptionally high energy use for air conditioning. Each proposal will be met with fierce resistance. Arguments over cost, personal freedom, and government overreach will echo the debates over water conservation a decade earlier. But the calculus of the heat is unforgiving. Unlike water, which can be stored, recycled, and managed, ambient heat is a totalizing force. You can't drill a tunnel to escape it. By the midpoint of the coming decades, some experts predict the emergence of a new kind of refugee, the climate refugee from within the United States. People leaving cities like Phoenix and Las Vegas, not for economic reasons, but because the climate has become unlivable for them and their families. It will start as a trickle, a family deciding not to move to Vegas for a job, a retiree choosing a cooler climate. But as the heat waves become longer, more frequent, and more intense, that trickle could become a flow. This presents an existential threat to the city's growth model, which has always depended on a steady influx of new residents. A city that stops growing is a city whose economic foundation begins to crack. And if you're just absorbing the sheer scale of this interconnected crisis, and you haven't subscribed yet, here is your friendly reminder. I understand this might be the second time I've asked, but the reality is this: for every 100 people watching this documentary right now, maybe one is actually subscribed. We need to change that. Your support, that one click, truly powers everything we do. It's what keeps this kind of analysis alive. Thank you. The scientific community watching Las Vegas is not panicked. They are grimly resigned. The scenarios playing out in 2026 are not surprises. They are the direct, predictable consequence of atmospheric physics. The carbon dioxide and other greenhouse gases pumped into the atmosphere have trapped heat, and that heat is not distributed evenly. It is concentrating in places like the American Southwest. The climate models, once seen as abstract academic exercises, are now looking more like operational forecasts. What scientists were warning about for the year 2050 is now happening in 2030 or 2026. The timeline is compressing. Paleoclimatologists studying tree rings and sediment cores have uncovered evidence of past megadroughts in the region. They are now also looking for evidence of mega heat periods. What they are finding is unsettling. The current warming trend appears to be pushing the region into a thermal regime that may be unprecedented in the last 2,000 years. The system is entering a new state, one for which our modern infrastructure and our modern society have no reference point. The past is no longer a reliable guide for the future. This is the most terrifying part of the 2026 heat wave. It will not be the peak. It will be a new baseline. The records broken in that summer will become the averages of the next. The emergency measures put in place will become standard operating procedure. A city that has prided itself on its ability to constantly reinvent itself will be faced with a problem that it cannot outbuild, outspend, or outgamble. It is a problem of fundamental physics. The response from the city government and the state will be a frantic attempt at adaptation. They will invest in cutting-edge weather forecasting, developing block-by-block heat vulnerability maps to identify the most at-risk neighborhoods. They will partner with tech companies to create apps that warn citizens of dangerous heat exposure in real time. They will try to engineer their way out of the crisis, because that is what Las Vegas has always done. But there is a growing chorus of voices, from climate scientists to urban planners, who argue that adaptation has its limits. At some point, the energy and resource cost of keeping a city like Las Vegas habitable in a much hotter world becomes unsustainable. At what temperature does the system break? Is it a sustained 115 degrees? A week of 120? A single day at 125? No one knows for sure, but the city is essentially running a live experiment to find out. The third straw, the billion-dollar tunnel to save the city from drought, was a monument to human ingenuity. But it was a solution aimed at a symptom, not the cause. The cause is a global energy imbalance, and its most potent expression in the Mojave is heat. You can drill for water, you cannot drill for cold. The crisis of 2026 forces an uncomfortable, almost philosophical question. Was Las Vegas a mistake? Was the creation of a massive metropolitan area in one of the hottest and driest places in North America a display of human ambition and resilience? Or was it an act of profound, multi-generational hubris? For decades, the answer seemed obvious. The city was a triumph. It worked. It grew. It created wealth and fantasy in an empty quarter of the continent. But the heat wave of 2026 will suggest a different answer, that the city's success was not a permanent victory over nature, but a temporary truce. A truce whose terms are now changing unilaterally and without negotiation. The city isn't just getting hotter. The very character of the heat is changing. It is becoming more humid. Historically, Las Vegas's heat was famously a dry heat, which allows the human body to cool itself relatively efficiently through the evaporation of sweat. But as climate patterns shift, and as the city itself puts more water into the local environment through irrigation and cooling towers, the humidity levels are slowly ticking up. This is measured by something called the wet bulb temperature, a complex metric that combines heat and humidity. It is a direct measure of the air's ability to cool the human body. As the wet bulb temperature rises, a person's ability to survive outdoors, even in the shade with plenty of water, plummets. When the wet bulb temperature reaches 95 degrees Fahrenheit, 35 degrees Celsius, even a healthy human resting in the shade cannot prevent their core body temperature from rising to lethal levels. The southwestern United States is one of the few places on Earth where future climate models predict wet bulb temperatures could begin to approach this theoretical limit of human survivability. Las Vegas is not there yet, but every tenth of a degree the humidity rises on a 115-degree day pushes the city closer to a boundary that is not engineering, but biological. This changes the nature of the threat entirely. A threat that can be managed with shade and water becomes a threat that can only be managed with refrigerated, sealed environments. Life outside of a building or a vehicle ceases to be merely uncomfortable. It becomes impossible for extended periods. This has profound implications for the social fabric of the city. Parks become unusable. Community gatherings move indoors or online. The simple act of walking a few blocks becomes a calculated risk. The city becomes a collection of air-conditioned islands connected by air-conditioned corridors and vehicles. The public realm, the space where strangers interact and a community is formed, evaporates under the heat. Consider the psychological toll. Living under a persistent, life-threatening environmental stress has consequences. Studies have linked extreme heat to increased levels of anxiety, depression, and even aggression. The constant low-level worry about the power grid failing, about a vulnerable family member, about the simple act of being outside creates a cognitive load that wears people down. The feeling of being trapped, of being under siege by one's own environment, is a new and deeply unsettling reality for a city built on optimism and endless possibility. The heat wave of 2026 and the ones that will follow it will force a reckoning that has been delayed for decades. Las Vegas will have to decide what it is willing to sacrifice to continue existing in its current form. Is it willing to accept permanent and mandatory restrictions on energy use? Is it willing to invest tens of billions of dollars not in new attractions but in boring essential infrastructure like undergrounding power lines and massive-scale cool surfacing? Is it willing to fundamentally rethink its growth model, perhaps even accepting a future where the city is smaller, denser, and less dependent on the automobile? These are not technical questions. They are questions of values. They will be answered not by engineers, but in contentious public meetings, in state legislature debates, and by the individual choices of millions of people. The city will be at a crossroads. One path leads to a future as a hardened, high-tech fortress city, a hyper-engineered bubble of climate control that is both incredibly expensive and socially stratified. The other path is one of managed retreat, of slowly and deliberately reshaping the city to be more in tune with its environment, even if that means abandoning the model of endless growth that has defined it for a century. We're approaching the end of this story, but tragically, not the end of this problem. And hey, third time's the charm, right? If you've come this far on the journey with us, you're obviously a part of the core community that appreciates this work. So if you haven't yet, please take this moment to hit the subscribe button. It's the only way we can continue to bring these critical stories to light. Thank you for being here. Ultimately, the story of Las Vegas and its battle with heat is not a local story, it is a planetary one. It is a preview of the choices and challenges that will face cities all over the world as the climate continues to warm. Phoenix, Dubai, New Delhi, Seville, they are all watching Las Vegas. Whether they know it or not, the city that has long been a caricature of American excess is now becoming a laboratory for urban survival in the 21st century. The lessons learned here, in failure as much as in success, will be written in asphalt, concrete, and human lives. The heat wave of 2026 will eventually break. The temperatures will recede to more manageable levels. The city will take a collective breath. The immediate crisis will pass. But something will have fundamentally changed. The illusion that the heat was a temporary inconvenience, a seasonal annoyance, will have been shattered for good. It will be understood as a permanent condition, a feature of the landscape as real and as immutable as the mountains that ring the valley. The city will have looked into the face of its own physical limits. The infrastructure held, but just barely. The social systems bent, but did not completely break. The fight was not won. It was merely survived. The real story is not that Las Vegas will face a brutal heat wave in 2026. The real story is what it will do the day after, and the year after, and the decade after that. Because the heat is not going away. The sun is not negotiating. And the desert, which was there long before the first neon sign was ever lit, will always have the final say. The engineering can buy time. The policies can soften the blow. But the clock that is running is not a human one. It is a geological one, and it is ticking faster than anyone ever thought possible.